Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today we're going to talk about a significance test for one mean. Anne reads that the average price of regular gas in her state is $4.06 per gallon. It is known that the distribution of gas prices in her state follows a normal distribution. To see if the average price of gas is different in her city, she selects 10 gas stations at random and records the price per gallon for regular gas at each station. The data resulted in a sample mean of 4.038 and a standard error of 0.0169. Do the data provide convincing evidence that the average price of gas in Ann City is different from $4.06 per gallon? Well, first off, if we're going to run a significance test, we want to go ahead and define the parameter that we are going to be investigating, which is mu equals the mean gas price. The null hypothesis is that mu equals $4.06, and the alternative is that mu does not equal $4.06. Next, we would name the procedure. This is a one-sample t-test for mu. We do have a random sample of gas stations. The 10% condition is met because 10 times 10 is 100, which is less than the population. We can assume there are more than 100 gas stations in the area. And the population is normally distributed, so our normality condition is met. Now, for calculations, this gets a little tricky. We were given the sample mean and the standard error of the sample. So we can't just plug this into our calculator. Here we're going to have to use the formula here, which is our t-test statistic, is x bar minus mu divided by the standard error of x bar. Plugging those numbers in, we get 4.038 minus the mean of the population, or the mean from the null hypothesis, 4.06, divided by that standard error of 0.0169. This gives us a t-test statistic of negative 1.3018. Now, on our t distribution here, the mean, just like with our z's, is 0. And we found this negative 1.3 and some change test statistic. So this area over here is going to be part of our p-value. To find that area, we're going to use t-CDF. Just like we had a normal CDF, now we have a t-CDF. Our lower boundary is something really small, like negative 100. Our upper boundary is that t-test statistic, negative 1.3018. And she sampled 10 gas stations, so the degrees of freedom is 9. This results in an area there of 0.1127. However, you'll recall that our null hypothesis was a not equals to. That means that we have to mirror that area to the right as well. So we're going to double this value to get our final p-value. So our p-value is going to be, that should be 0.2254. My apologies. 0.2254 is greater than alpha of 5%. Hence, we're going to fail to reject the null in favor of the alternative. There is insufficient evidence to suggest that mu equals the mean gas price in Ann State is not 4.06. I am going to point out here that we have a numerical comparison between the p-value and the alpha. We have a decision. We fail to reject the null in favor of the alternative. Don't forget that, in favor of the alternative. And then we're going to give a second sentence, which is the context of that decision in terms of the null hypothesis. So there's insufficient evidence that it's not $4.06. I hope you found today's video helpful. I'll leave you with this quote by Edwards Deming. Have a great day.